millimeter base.
So I have a friend at work that keeps asking me questions about 3D printing, and pretty much anytime I say that I own a 3D printer, they have about a million different questions. So I want to go from start to finish and be able to explain all the intricate details of what makes a 3D printer work, to getting the files ready to print, to maybe even doing a little bit of finishing work after the print is done. So let me go ahead and go over the components of the 3D printer. First of all, you got your control box. Now your control box is going to receive the information, so you'll be able to hook up your USB or your SD card. I run off SD card because the USB, if for something fails on the computer, then your 3D print is going to be ruined. So I like to run off something that's a direct connection to this that already has the information. So the control box is going to be ran to all your different components, mainly your stepper motors. Now your stepper motors are going to be running off 3 different axes. You're going to have your X axis, your Y axis, and then also your Z axis. As you see, these threaded rods will actually run up and down to lift this whole bridge up. So once you control those 3 different access points, you can be anywhere on this board at any time you want. So with this point here, it's going to be run. It's an actual hot end, so it's actually going to have a heating element in there that's going to make your plastic molten and heat it up. And it's a point that's literally 0.4 millimeters thick. So that hot plastic is going to be injected out of there and pushed out directly onto this hot plate. It's a hot plate because basically what happens is when you have molten plastic, you want to make sure it sticks. That's one of the biggest things about 3D printing, is making sure that your prints actually stick, and we'll go over that later. So it's going to go through this, and then you're actually going to have what's called an extruder motor. Now this extruder motor is actually going to be pushing a filament that's 0.75 millimeters thick that you buy from the store. It's around 20 to 30 bucks depending on what kind of quality and grade and types. You have many different types of plastic you can use. We're using a PLA because it's non-toxic, it's not as dangerous. So let's move on to the design aspect, and then we'll go back to this to get everything set up. Okay, so the first thing we're going to do here is we're going to go to Thingiverse. So Thingiverse is going to have a million different things you can 3D print, and the guy who wants me to print something for him, he's wanting a Springfield, like, quick loader thing, so we're just going to search Springfield here, see what pops up. There it is, speed loader right there, and we're going to click on that, and then move on. And what you can do here is we can kind of view the image and kind of see what it is, and we can actually look at the orientation. If you go to the thing view there, this will give you an opportunity to kind of rotate it around, make sure it's in the right position, and see how it's orientated and if it's a good shape to print. So and also another thing to look at here is in the instructions is, you know, layer heights or any kind of things, use supports or not use supports. And then the only other thing to actually check out are licensings. You don't want to print something and then sell it and you're not supposed to because it was proprietary or it wasn't yours, you didn't have the rights to it. So we're just going to give this to him, so we're not going to be spending we're not going to be making any money on it or anything like that. So the next thing is I'd like to customize this for him. So I'm going to search Punisher here. He said he has a Punisher logo on his gun already, so I'm going to look and see if we can find anything. There we go, just that first Punisher skull will work. I don't really like to just print something just the way it is. I want to customize it and make it look unique. So we'll go ahead and download that file as well. Now that we got these downloaded, we're going to go to what I like to call, or what is called Tinkercad. It is actually a 3D software online, so you don't have to download anything. It'll save all your files. It's really cool because you can show people what you've done and that kind of thing, no matter where you're at, as long as you have a computer and internet connection. So we're going to go create new part here, and then we'll just drag these parts in here. We'll click import and then drag in the 9mm magazine thing, and there it is, popped up. So, and then we also want to get the one thing I want to show you here real quick is you see how the view looks? We're going to switch to Orthographic View, and basically what that means is it's going to be a straight-on shot. Perspective is how you'd see it in real life, and when you're trying to line up parts and that kind of thing, you want to make sure that you're using Orthographic View, or it's going to really kind of mess with you. So we're going to put in the Punisher thing here, and let it load, and there it is. So we're going to try to orientate this in a certain way. Now I think the way the magazine speed loader is orientated, it's actually upside down. So I think I'm going to rotate this down to upside down, so that way it'll be the right orientation when it's the actual part. So another thing there, I really like this. You can click, when you click the top, front, right, whatever it is, you know that it's locked into that space, and you know it's correct. So we're going to put this at 90 degrees, and then we're going to click the front view here. Now we know that's all square and evened up. If that was in perspective, it would give you a completely different view, and you wouldn't know how lined up it is and that kind of thing. This is going to be a straight on shot, so you know everything lines up just how you want it to. I'm also pressing shift when I do this to make sure that all the proportions stay the same and it looks correct as well. So we'll get this kind of squared up on the face of this, and once we get that squared up to the face, let's kind of make it a little bit bigger. There we go. And then we'll change the orientation to maybe like the top view here. Let's rotate this around. The top view here, and we're going to actually, what we're going to do is actually make kind of a cutaway of this object. So what I'm going to do is I'm going to push it in to where I know it's just going to be making a little bit of the surface area cut away there. And I want to do it on both sides, so we're going to duplicate this and put it on the other side as well. So there's both our cutaways, and then we're going to make these, instead of a solid, it's going to be a hole, and this will actually just cut it away from whatever material you're using. And then we'll go and select all these parts all together and group them together. Now we got that, and there's our part. Everything looks good, and that's how it'll look. So now that we've got this, we need to export it. So we're going to go to export. We're going to go to STL file, and there it goes. It downloads it. I probably should have given it a name, but whatever. It's just one-time part thing anyway. So I'm going to click on that, and this is going to open up Cura. This is a slicer. A slicer basically means that it's going to give the 3D printer the directions it needs to do everything it needs to do. So the 3D printer actually isn't as smart as what you think it is. It's basically just given a list of instructions. This motor needs to do this motor needs to do that, and it does what it's told. So if you give it a bad list of instructions, it will do bad. So you see the view mode here. We're going to click, we got scale, rotate, mirror, and then we're going to go to view mode, and we're going to click layers. Now layers, this is actually going to show you exactly what's going to print. It's going to show you exactly what it looks like. So if you can zoom in here, you see how you can see all the material, and then we can actually see how many layers it has. There's 200 and so on layers. What this means is that's exactly how many layers it is. So say for instance I wanted to get a higher resolution out of this. I got it at 0.2 millimeters right now. I can change it to like 0.1 millimeter. And if you look over in the view mode layers, the number from 265 will change to, let it slice, 5 makes sense, 528. So 528 means that there's that many more layers in the print because it's only going up 0.1 millimeters Z height, and it will slowly do that as it prints. So we're going to do 0.2. This isn't anything fancy. Actually, the thicker you print, the stronger the part actually will be. The more detail you get out of a print, technically it shouldn't be as strong because you got more layers in there and chance for delamination. So, and you can change in the views. Like this is all just the support material that's inside the actual infill of the object, and then we have our support. You can actually even, if you see the kind of the blue lines there, that's how the needle is actually going to travel. They'll give you the full travel of how this whole thing is going to move as it prints. So now that we got our slicer already, things to think about is speed, and then of course support. An object like this, if you didn't have support on it, you could really risk actual needle knocking it over as it prints. Almost guaranteed too, probably, with the lack of surface area there. The 45 degree really isn't that big of a deal. You could probably print that up. It'd give you a little bit of roughness, but it could probably print that. But it's more of the needle actually catching or tapping it at all and knocking it over. And I don't want to risk that, definitely for a single time one print type deal here. And you can see where the supports, it's actually not even touching it, but whenever it prints, and it will actually hold it up just a tidbit, just for, safety reasons. I don't want to have to print this twice and waste material. So we're going to go in here, and also one thing here, the skirt, nice thing to do is go ahead and print a skirt on this, and that's just a little brim around the material just to get it started, so that way you have plastic being injected out right at the beginning of your print. You don't want it to be kind of spotty at the beginning. You want to make sure you got enough out, so that skirt really helps with that process. So we're going to go ahead and save the file here. Okay, so we're about ready for our print, so I want to make sure that I get the surface ready. There's a lot of different ways that people do this. When I first started, I actually started with like a masking tape. That's actually what came with this printer. And it works really well. It sticks to the print very good. But the problem is if you have a really large flat surface area, it actually is almost nearly impossible to get off, definitely if you do it correctly. So I finally moved on to a piece of glass and some just Aquanet hairspray. A lot of people on YouTube do this as well. But all you gotta do is just put on a nice little layer like this, and it'll be kind of wet, and I like to just kind of smear around and smooth it out just a little bit, just to kind of get it evened out on there. And then once the heat bed warms up, this will actually level out, and it'll be real nice and smooth, and it'll be very, very tacky, and it'll keep your print from out moving. The big deal about this is if your print moves at all, you're done. The print's done. So you have to make sure that once this first layer gets stuck down, that it's good all the way through, because if it moves, it won't be in the exact position, because this is all about precision and being right in the right spot. So we're going to go ahead and get our SD card, plug it in, and start the print. And there's our 3D print. It's all ready to go. We've got the supports. Break it off here. The supports will just break off there. And there it is.